Welcome back, geometry students. In this lesson, we are going to be answering some questions related to slopes and equations of lines. Let's get started. So the first question asks us to determine the slope of this line. Now, I could use the slope equation, y2 minus y1 over x2 minus x1. That would give me the rise over run. That works, but instead, for one like this, it's easier to just count the rise over the run. So for letter A, I'm just going to be doing rise over run equals, let's see, what is the rise? 1, 2, 3, 4, 5, 6. The rise is 6 over a run of 1, 2, is it just 2? 1, 2. 6 over 2. And I need to simplify my fraction here. 6 over 2 equals 3. It has a slope of 3. What that means is for every 3 I go up, the run is 1, because 3 is 3 over 1, right? So it's 3 up over 1, 3 up over 1. How do I know it's up and not down? Well, 3 is positive. A positive slope means I go up for my rise and then over to the right. I always go over to the right, even if the slope is negative. So up 3 over 1, up 3 over 1. I could also go up 6 over 2, up 6 over 2. Same thing. All right, letter B. Use the slope formula to find the slope of the line passing through 1, 2, and 3, 4. Well, this is easy. y2 minus y1 over x2 minus x1. The y-coordinate of the second point, that's y2, is 4. The y-coordinate of the first point is 2. That's y2 minus y1 over x2. The x-coordinate of the second point is 3. Minus the x-coordinate of the first point is 1. Why, this is going to equal 2 over 2 or just 1. So if for a slope of 1, I go up 1 over 1, up 1 over 1, up 1 over 1, because 1 is just same as 1 over 1. All right, there we go. Letter C. Use the graph to write an equation of the line. I am going to do this in the magical slope-intercept form because that is the way that's easiest to write an equation of a line. Okay, I'm going to zoom in on this just a little bit so we can see it a little closer. I notice that my y-intercept is 4. I cross the y-axis at the number 4. So I'm in slope-intercept form. That's my b, mx plus b. So I'm just going to plug in 4 for that b value. And then if I look at the slope, I notice I'm going down 1 over 2, down 1 over 2. Anywhere I find a point where the line crosses exactly at a crosshairs on the graph, from there I go down 1 over 2, down 1 over 2. Okay, so let's think about this for a second. What is down 1 over 2 in slope form? Well, let's see. I'm going to write y equals, I need a slope. Down 1 is negative 1 for a rise, over 2 is over 2, 2 for my run. Down 1 over 2 is negative 1/2. It's going to be y equals negative 1/2 x, because the slope is always the number multiplying the x, plus my y-intercept is 4. See how easy it was to write that equation? I didn't have to do too much work at all. There are more labor-intensive ways of writing equations. I'm not going to worry about any of those because that was so easy. All right, letter D. Let's see. Write the equation of the line that has a slope 3 over 2 and passes through 4, negative 1. This one is going to be tricky. We have to hearken back to our days of yore in algebra to do this one, but I think we're going to be okay. So I know that this is going to have a general equation, y equals mx plus b. And I know that m is the slope. M has to be 3/2, but I don't know what the y-intercept is. I'm not given a y-intercept, but I am given a point that is a solution to the line. This isn't a real xy point that is a solution to this line. So what can I do? I'm going to plug that in as x and y. The y value of 4, negative 1 is negative 1. So I'm going to plug in negative 1 for y. Negative 1 equals 3 over 2 x. Oh, wait a second. I don't have to use x. I can plug in the x coordinate of the point I'm given, 4. 3/2 times 4 plus b. Now I can solve for b. So looking at this, it's going to be -1 equals 3 halves times 4. 3 halves times 4. Well, that's just 3 halves times 4 over 1. 12 halves. 3 times 4 is 12. 2 times 1 is 2. So it's going to be 12 over 2 or 6. Do whatever you need to do to prove that to yourself. 3 halves times 4 is 6. Okay, plus b. Let's get b on a side by itself so I can figure out what b is. To do that, I am going to subtract 6 from both sides of this equation. And that's going to give me b equals -7. Well, -1 minus 6 is -7. Hey, if b equals -7, and I know the slope, now I know what the equation is. It's going to be y equals, there we go, y equals, and let's see, it has to be 3 halves x and plus -7, or I could just write -7. Okay, so I found the y-intercept by using the 1 point I was given, plugging that in for x and y with my slope, and then solving for the y-intercept. Once I know the y-intercept, I could just plug that into my slope-intercept form equation, and I am done with that one. Letter E. This one's also a little harder. We're going to have to harken back to our days of algebra. Write the equation for the line that passes through 0, -2, and 5, 2. Well, wait a second here. If an equation passes through a point that has 0 as the x-coordinate, that is the y-intercept. That is the 0. The y-intercept is where x equals 0. So I know the y-intercept is -2. All I need for this one is the slope. Well, I know that the slope equals y2 minus y1. That's 2 minus -2. Okay. Divided by, by the way, that's the rise. y2 minus y1 divided by x2 minus x1. Well, x2 is 5, x1 is 0, so it's going to be 5 minus 0. So this is going to equal, see, 2 minus a -2 is the same as 2 plus 2. The slope here is 4 over 5. And, okay, so I know the slope is 4/5. I know the y-intercept from the point 0, -2. Otherwise, if I didn't know the y-intercept, I would just write this out in slope-intercept form like we did before. Y equals, let's see, it's going to be 4 over 5 x plus b. Okay, hold on a second. I'm going to put a degree of separation there so we can see this a little better. And maybe just slide this whole thing up just a little bit. All right, anyway, now, if I didn't know what b was, all I'd have to do is plug in one of my points. I would choose to plug in 0, -2. If I plug in 0 for x and -2 for y, I see b equals -2. Well, b equals -2, so I'm just going to replace b with -2. Y equals 4/5 x minus 2. All right, again, we're hearkening back to our days of algebra to make this work. All right, now, for f and g, we're going to cheat and use the fact that these are in slope-intercept form because that's going to make this really easy. I have to graph the line with the equation y equals 3 minus 1/3 x. Well, the number multiplying x is the slope. In this case, it's minus 1/3. That means I'm going to go down 1 over 3, down 1 over 3. Down 1 over 3 from where, though? Well, first of all, I need to put a point on here that's at the y-intercept. The y-intercept is positive 3. It's the constant on this side. So the it's going to cross the y-axis at 3. I'm just going to put that point on there. There we go. There's my y-intercept. And now from that y-intercept, I'm going to go down 1 over 3. Down 1 over 3. I'm just going to start up here. I'm going to go, if I go up 1, I can go back 3. Up 1, back 3. I have to go the opposite direction if I'm going this way. Okay, it's going to go down 1 over 3. Down 1 over 3. So my line is going to look like, if I did a better job lining this up, it would be a little better. It's not terrible, but it's not great. So it should go down 1 over 3, down 1 over 3, cross through here as the y-intercept, down 1 over 3, down 1 over 3. Now, if I were drawing this with a straight edge, it'd be a little easier than putting it on my computer. The other thing I'm going to do is make sure there's an arrowhead on both sides because it's a line. All right, now let's graph this other one. But before we graph the other one, I have to put it in that magical slope-intercept form. How am I going to do that? Well, I need to get y on a side by itself. Right now, 3x is being added to y. 3x plus y equals 6. So what am I going to do about that? Well, what I can do about that is subtract 3x from both sides of this equation. Okay, as long as I do it to both sides, I'm okay. Minus 3x. So what this gives me, 3x minus 3x cancels each other out. Y equals negative 3x plus 6. Now I have slope-intercept form, and this is quite easy for me to graph. Where am I going to have my point? Well, my point, let me just get a point here. My point is going to be at 6, positive 6 on the y-axis. 1, 2, 3, 4, 5, 6. It has to be up here. And why is it up there? Because that's my y-intercept. My y-intercept is 6. From there, my slope is negative 3. So that means negative 3 is the same as negative 3 over 1. My rise is down 3, and my run is over 1. So I'm going to start up here, and we're going to go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. Let's see if we can make it look pretty good down to here. Hey, that's pretty good. Okay, so I'm just going to put an arrowhead on both sides of my line here, and then we should be good with so there's a y-intercept of 6 and a slope down 3 over 1, negative 3, down 3 over 1, down 3 over 1. Okay, so that is how you work these types of problems using the equations of lines to find slopes, or using the information that you're given to find the equations of lines. You are now ready to begin the next lesson. Do numbers 1 through 30 in lesson 16.